Hello, Year 3. Welcome back to your Roald Dahl Day activities. This is your second maths activity for today. It's separated into sections like A, B, C, and D, and we'll go through it together. Make sure you have your paper and pencil ready because I will need you we'll talk through some of them, and then I will need you to do the rest of the activities yourself. So this is activity 2A. So you can label that on your piece of paper, making sure that the A is clear so I know which answer corresponds with which question. So the question is, a Wonka chocolate bar has 5 rows with 5 squares of chocolate in each row. How many squares of chocolate are there altogether? You have 3 sections to be able to complete this answer to find out how many squares of chocolate there are altogether. So firstly, can you have a go at drawing this as an array? Pause the video, have a go at doing this, and then we'll have a go together. Okay, so we want to draw it as an array, remembering that when you're drawing an array, there needs to be the same number of pieces in each row, chocolate pieces in each row. So it says we have 5 rows. So I can start representing my 5 rows. 2, 3, 4, 5. So I've got 1, 2, 3, 4, 5 that I'm going to represent as rows like this, going horizontally. Now it says there are 5 squares of chocolate in each row. So I'm going to complete my array to represent this. Here's 1 piece of chocolate, 2, 3, 4, 5. Now that I've started it off, if you struggle to represent your chocolates as an array, can you have a go at completing it now? So pause the video, have a go and play the video when you're ready. So I've just completed 1 row of 5, 1, 2, 3, 4, and 5, and I'm going to complete the rest. 2, 3, 4, 5. In order for my representation to look like an array, I'm going to make sure that it's organized. So all of my pieces of chocolate are represented underneath each other neatly. Now the third row, 1, 2, 3, 4, 5, 2, 3, 4, 5, and last row, 2, 3, 4, and 5. Okay, I've now drawn this as an array. The next part is, can you write an addition number sentence to represent this? Pause the video and have a go at doing this yourself. You can even have a go at doing the last one yourself if you want to, and then I'll show you how to do it together. Okay, can you write this as an addition number sentence? So we know that in each row we have 5 pieces of chocolate. 1, 2, 3, 4, 5. So I can represent this as the number 5. And I know in the second row I also have 5 pieces of chocolate. So 5 plus 5. And in the third row, I have 5 pieces of chocolate, so I need to add another 5. And in the fourth row, again, I have got 5 pieces of chocolate. And in the last row, I also have 5 pieces of chocolate. Which equals, now how could you count this in a way that makes it easier for you rather than counting them one by one? Well, we know that they are organized in rows of 5 or in groups of 5, so we can count in fives. Let's have a go at counting in fives together. 5, 10, 15, 20, 25. So there are 25 pieces of chocolate all together. If you haven't had a go at doing this last question, pause the video, have a go. It wants you to write a multiplication number sentence to represent this array or represent the number of chocolates all together. Pause the video, have a go, and play the video when you're ready. Okay, so we know that we have 5 rows. I'm going to circle these 5 rows to make them clearer. That's 1 row. 2 rows. 3. 4. 5. Okay, what do you notice about each of these rows? Well, we have 5 rows with 1, 2, 3, 4, 5 pieces of chocolate in each. So we have 5 groups and they have an equal number of pieces of chocolate. So we have 5 equal groups of 5. So how could we represent this as a multiplication number sentence? Well, remember that the first number or the first number in a multiplication number sentence represents the number of groups where we have 1, 2, 3, 4, 5 groups. And the second number in a multiplication number sentence represents the number of items in each group. How many items do we have in each group? 1, 2, 3, 4, 5. So 5 times 5 equals, if you remember your 5 times table, you will remember that 5 times 5 equals 25. Or again, we can count in fives together. So 5, 10, 15, 20, 25. So both of these questions answer the first question. How many squares of chocolate are there altogether? There are 25 squares of chocolate altogether. Once you finish this question, we're going to move on to the next one. Okay, this is activity 2B, so make sure you label that clearly on your piece of paper. If every lunchtime Mrs. Bucket used 3 heads of cabbage, how many heads of cabbage would she buy in a week? What information would you need to know to answer this question? Well, you know that Mrs. Bucket used 3 heads of cabbage in every lunchtime, so the number 3 is important. And also, we want to know how many heads of cabbage would she buy in a week? So how many days are there in a week? 1 week is equal to 7 days. So how could you answer this question? Pause the video, have a go, and play the video when you're ready. Okay, so we know that Mrs. Bucket uses 3 heads of cabbage every lunchtime. We also know that 1 week is equal to 7 days. So how would I know how many heads of cabbage she would need to buy in a week? Well, I know that for 1 day, she needs 3 heads of cabbage. Then for the second day, she will also need 3 heads of cabbage. The same for the third day. And the fourth day. And the fifth day. And the sixth day. 1, 2, 3, 4, 5, 6. I have added my heads of cabbage for 6 days. I now need to add it for 1 more day to make it a week. So how many heads of cabbage would you need for the whole week? Have a go at counting these in 3s by yourself and play the video when you're ready and we'll count together. Okay, let's start with 3, 3, 6, 9, 12, 15, 18, 21. So she would need 21 heads of cabbage for that week. Is there another way of representing this? Think about how we answered the previous question. Is there another way other than an addition number sentence to represent this? If you can think of another way, make sure you write it down clearly on your piece of paper before we move on. Okay, this is activity 2C. If a Wonka chocolate bar costs 50p, how many could be bought with £5? Here's a little reminder for you. Remember, £1 equals 100 pence or 100p. So being given this information, how could you use this information to help you figure out how many bars of chocolate could be bought with £5? Pause the video and have a go. Play the video when you're ready. Okay, so we know that 1 chocolate bar costs 50p. So how many pence or pounds would 2 chocolate bars cost? Well, if the cost of 1 chocolate bar is 50 pence, plus another chocolate bar, what is 50 plus 50? Well, 50 plus 50 equals 100. What do we know about 100 pence? Well, we know that 100 pence is equal to £1. So 50p plus 50p equals 100 pence or £1. Can you use this information to help you figure out how many bars of chocolate could be bought with £5? Make sure you show you're working out clearly on your piece of paper. So pause the video, finish the question, and write down your answer clearly before we move on to the next question. Okay, the next question, activity 2D. Make sure you label D clearly on your piece of paper. It says, Charlie has 90p. He goes to a candy store and wants to buy some sweets. Which sweets could he buy? So which piece of information is important for us to know? Charlie has 90p in total. That's the total amount of money that he has. Which sweets could he buy? Charlie could buy more than one item of each sweet as well. So keep that in mind for answering this question. Pause the video and have a go at thinking about which sweets he could buy. We've got a Wonka bar for 50p, Smarties for 20p, Skittles for 30p, candy canes for 10p each, and gummy wheels for 5p each. Pause the video and have a go at working it out. Play the video when you're ready. Okay, well, there may be many different combinations of sweets that he can buy. So Charlie has 90p. Well, with 90p, he could buy one Wonka bar for 50p. Plus, which other sweets could he buy? Could he buy another Wonka bar? No, because we know that 50p plus 50p equals 100 pence or £1, which is more than what he has. So he can only afford to buy one Wonka bar. Which other sweets could he buy with his 90p? Could he buy Smarties? Well, let's see. 50p plus 20p. What is 50 plus 20? 50, 60, 70. So that would equal 70p. He still has some money to spend. So which other sweet or which other candy could he buy? 50p plus 20p. So far he has spent 70p. Could he buy a pack of Skittles? Well, he spent 70p already. 70 plus 30 equals 100 pence. So he could not buy a pack of Skittles on top of what he's buying now. Could he buy a candy cane? He could, because 70p plus 10p equals 80p. And he still has some money to spend. He spent 80p and he has 90p to spend. What else could he buy? Could he buy another candy cane? Yes, he could, because 80p plus 10p would equal 90p. Okay, so this is one example of the combinations of different sweets that Charlie could buy. Can you think of any other combinations? Make sure you list your combinations down clearly before you move on to the next question. So pause the video if you need to. Okay. Activity 2E. Mr. Bucket worked at a toothpaste factory where he screwed the little caps onto toothpaste tubes. If Mr. Bucket screwed on 100 tops an hour, so there are two pieces of information there that are important. Per hour, he screwed on 100 tops. How many would he screw on in an 8-hour day? So we know that he screws 100 tops in 1 hour. So how many would he screw on in an 8-hour day? Have a go at doing this by yourself. Pause the video to finish your question and play the video when you're ready. And your last question is a challenge. Here's a list of chocolate bars and their prices. Can you come up with your own maths questions related to these chocolate bars? You can write down these questions and have a go at answering them yourself, or you can just write down as many questions as you can think of to do with this list of chocolate bars and their prices. Make sure you upload all of your work onto Tapestry, and I look forward to seeing all of your great maths work. Well done, Year 3. Bye.